So I want to do one quick housekeeping item before we kick off the session, and that has to do with sound in this room. I know yesterday we had some issues. For those of you in the back of the room, if for some reason you aren't hearing Mike giving his presentation, please raise your hand. Don't feel bad about interrupting. We'd rather adjust the sound and make it so you can enjoy the presentation that he's giving today. So definitely raise your hand, make a symbol, let us know so we can get that adjusted. And with that, because I know you don't necessarily want to hear from me, I'm going to pass it over to Mike Bowers and his presentation on becoming a document guru.
All right, so this is about data modeling and how do you get from the relational world into the document world. And I believe that the future is the document graph data model. So you've seen the abstract, it's online, but the main points that we're covering, I'm covering everything in the abstract, but I'm also focusing on this. Relational modeling has, I think, at least two flaws. Number one is you're taking business identities or business entities, whatever you want to call them, a business thing, and that, like a person, right? And you take the person and you shred the person. Now, how mean is that? Right? Well, you don't want to shred people, right? So if a person has emails, addresses, phone numbers, all those multiple S's, plurals, are all shredded off the person into other things, other tables. Right? And that's not natural, that's not human. It's actually inhuman, right? So we want to take things and make things more natural. A document can contain everything about a person. Everything that is intrinsic to the identity of the person is in the person document. And that's natural. So relation is unnatural, document modeling is natural. But you also have relationships between entities, right? A person orders something, right? And the transaction is an entity itself. It has an identity, right? We always put IDs on identities. So we put ID on a transaction. So a person who has an ID does a transaction, and the transaction is an ID. And then the transaction may have, it's an order, has products in it, right? And so each product has an ID. And then the product has vendors, and the vendors have IDs. So each of these identities are connected. And relational forces you into fixed connections. You have to, at design time, figure out what they are, create an entity relationship diagram, and then you go and write DDL to generate the data, and you put foreign keys in tables, and it's all fixed. So relational has the problem of fixed identities and fixed relationships between the identities. The real world is not fixed. Think about your brain. You are a semantic processing engine, right? You're a graph in your brain. You connect everything to everything in every way imaginable, right? And so in this room right now, you're connecting this room and each other to this presentation. You're connecting me to semantics and graph relational modeling, right? You're connecting to the tablecloth because it feels soft on your hand, and you're connecting that you don't have a table to lean against, right? You're all connecting everything to this conference, and it's millions of connections going on in that brain. And what does a relational model give you? A couple of relationships, and you have to hard code them. That stifles you, right? It limits your capabilities. And so we're going to talk about getting away from the fixed, stifling relational model into the future, which is documents and graphs. I'm Mike Bowers. I'm a principal database architect for the LDS Church. I've been doing NoSQL now for almost 10 years. In 6 months, it'll be 10 years. We brought MarkLogic into the church 10 years ago. I've been doing databases my whole career, which is way too long to say. And then I wrote this book on HTML and CSS back 2007. I'm writing a book right now on MarkLogic. It'll be published in about 6 months or so. So that's my focus is really databases and development. Why did I write an HTML book? Because it was a mess, and I wanted to clean up the mess in my brain and understand it better. So I wrote a book. So now we're doing the same thing with MarkLogic. We have at the church hundreds of applications in MarkLogic. We have over 200 applications. We have over 300 servers running MarkLogic. We have billions of page views annually. We're a church, and so on Sundays we have lots of major hits. All of our websites are in MarkLogic. We have lots of other kinds of applications on MarkLogic as well. So we've been doing MarkLogic for almost 10 years now, and we're very successful, and it's transformed everything we do. When I started working for the church 10 years ago, And when it got there, the websites were stodgy, slow. We were using old-style web content management systems, and you couldn't get anything into them or out of them. We switched to MarkLogic, and we transformed everything. We went from a few stodgy websites to now hundreds of websites, all powered by MarkLogic. But not just websites. We have metadata management apps in MarkLogic. We have some data apps in MarkLogic. We have custom content management systems. So we have all kinds of things now in MarkLogic. We haven't replaced relational with MarkLogic because there's a few things you still need to do in the product to fully replace relational. But with this new modeling technique, we can go beyond relational. And that's what this presentation is about. So we're going to talk about database modeling paradigms, relational to document, and then document graph. So it's the combination. It's not just document, it's not just graph, it's both. And then it's document advantages. Why do you want documents? So we're going to jump right in. There's 6 major data modeling paradigms, or ways to think about data. Number 1 is your traditional relational, right? You have fixed dense tables with flexible queries and joins. Your relationships are fixed, your tables are fixed, but you can join and connect different tables to each other in a very flexible way. Dimensional modeling is not very flexible, but it's very predictable. And it's very easy for end users to drag and drop dimensions onto a report and then filter the fact table, and you can get very quick results. So we have a fairly large warehouse. We have 5,000 tables in our data warehouse. We use the Kimball model. It's very successful in our organization. 10 years ago, we had 5 BI engineers. Today, we have 50 BI engineers. It works very well for us. But it's a different kind of modeling. And so it's not third normal. It's third normal form, but not. That's a technical thing. It's a different way to model. And that's the important part. Graph is a completely different way to model. It's very atomic, very small, very granular. And so you can do anything in graph, but you end up with millions of connections between things. Right? So the biggest problem when I talk to others and myself, when you do a big graph, you go like, okay, I just did a query and I got 1 million triples back. What do I do with that? How do I wrap my head around these complex graphs? But if you go to a simple document model, you can see it in one place. And what does the human brain do? We think in documents. That's why we invented books. Right? We invented forms that people fill out on paper, right? We think in terms of documents, not in terms of graphs. Although we have a graph processing engine in our brain, we don't think in terms of little graphs. We think in big concepts. We roll the graphs up into documents in our heads. So document is a very powerful structure because it's a grouping of little granular things into a context. The context is everything in a document. Because when I have context, I can compare and contrast groups of things. In a graph, I can compare and contrast groups if I write really complex queries, but usually you're comparing and filtering on little triples, right? But in a document, I can compare everything in this document with everything else in my entire database. And I can actually do calculations that give me the most relevant results back. So if you want relevance, you need documents. So documents are for relevance. Graph are for precise queries. We'll talk about the difference between search and query. But in a nutshell, search is about relevance order. Queries are about precise, logical, filtered results. You get everything back in a query that matches your logical predicates. And in a search, you're getting the most important results first. You might get millions of matches, but you don't care about the ones at the bottom because they're not relevant. You care about the top 50 or something. Then you have wide column. We're not going to talk about that here. That's like a Cassandra. Everything is super fixed there. We have key value. Again, we're not going to talk about that very much, but that is also fixed data structures. So I'm going to now talk about these exact same models in context of the entire database space. I didn't have time in this presentation to walk you through why I came up with the top 10 databases, but this data is based on Gartner. It's based on Forrester. A whole bunch of analysts. It's based on my experience for 10 years of being an analyst in the industry. That's my job, is to be an analyst of all database technologies for our organization to help us choose the right technologies. And I spent the entire last year working on Oracle. I mean, the entire year was on the Oracle database and our future direction where we're going as an organization. So that's my job in a nutshell, is to figure out the industry and make sure we're going down the right paths and make technology shifts in our organization. And we're a large organization. We have thousands of developers. We're just a big IT shop, multinational. So it's very important to us to choose the right solutions. If you look in this chart, on the far left, I have wide column. On the far right, I have graph. And the difference is everything on this left is very fixed structure. Everything on the right is very flexible. So the most flexible you can get is graph. The most fixed you can get is this wide column, like Cassandra. And as you get toward the middle, you get your traditional relational and dimensional. But notice that dimensional is more fixed than relational, right? If you think of the star scheme as a fixed structure, it does provide context for data, so it's more powerful in that way than relational, because relational takes everything out of context, but it's fixed. Relational is more flexible, but as you get toward a document, you're more flexible, and in graph, the most flexible. Now you notice when I say in the very beginning of our presentation that document graph is the future, notice what I just said. Flexibility, runtime modeling is the future, because it gives us the ability with data to define what our data means. And that gives you isomorphism. Isomorphism means same shape. So if your data structure is in the data, if your metadata is in your data, it self-defines what it is, and you can change it on the fly, and then you can create more metadata about the metadata, about the metadata, about the metadata, about the data, about the metadata. You know, you just go on forever. It bootstraps itself in a recursive way where you can do incredible things. So over here, when you're in dimensional and relational, you're fixed. You have a schema that's in a proprietary database tables that are different in Oracle, that are different in SQL Server, and you can query them, but the metadata is not the data that you need in your apps. It's separated from your data. If you can put it all together, you're more flexible. And so we're going to talk a lot about the flexibility. So notice the far left is very fixed, the far right is very flexible. On the upper, top, and bottom, it's about velocity and volume. So this is your 4 V's in your SQL databases. Velocity and volume on the top and bottom, and on the left to the right are about variety and variability. Where is your variety and variability? On the right. The only database that I know of, and I know a lot of databases, the only database I know of that really does variety and variability correctly and usably is MarkLogic. Okay, everything else is fixed. Cassandra is incredibly fixed. You know, and your key values are actually very fixed, or Redis is very fixed. You have fixed data structures, and you just pour your data into fixed structures, like linked lists. Now, data structures can be flexible all by themselves, but you're still pouring data into a fixed structure. On MarkLogic and Graph, you can create any data structure you want, and you can leverage it any way you want to. And you can do it at runtime. Okay, so let's move on now. This is the industry. These are the top 10 databases, and I put MarkLogic at number 6. Notice that's right behind Oracle and SQL Server and what is it, IBM and AWS Redshift for the warehousing part. But you know, there's a whole bunch of other databases I left off because they're not enterprise ready. So this is the top 10 enterprise databases. So how do we combine? Do we combine multiple models, and how do we do it? The answer is yes, we do combine them. Everywhere we go, we combine them. In relational, we combine them with dimensional all the time. How often do you have an operational database that doesn't have some data warehousing, right? I mean, of course, we have some of that, but in our organization, we always combine them. You know, they're separate databases. We use Exadata and SQL Server for our dimensional, and Exadata and SQL Server for our relational. Over here, if you're a Cassandra shop, you often will combine Cassandra and Redis because you're about high velocity and volume, and these are the best solutions for high velocity and volume. And notice they're both very fixed. You know, you're pairing like things. You know, over here, relational and dimensional are paired because they're right in the middle of fixed and flexible. Over here, super fixed, and then MarkLogic, document graph. It's not an accident that MarkLogic combines the two things that are the most flexible in data modeling, because they are the most flexible and useful, and it's the right paradigm. They inherited that from the W3C. W3C is the founders of the concept of XML and semantic graph. And so by implementing W3C, they implemented the right paradigm for a new kind of database. So MarkLogic is a multi-model database. It can do key value, because MarkLogic has a URI and it has a document, and that's key value. It can do your operational data warehouse. It can do SQL. They have a SQL engine. And MarkLogic can be a document warehouse. It can also be my favorite thing is your document database and your graph database. So notice it has a wide variety, but it is not a wide column database, because that's totally fixed. And to me, wide column is an anti-pattern for most use cases, and it's the best pattern for a few use cases. Variety is the future. And so MarkLogic is super flexible. Oracle is the only other database that comes close to MarkLogic in being multi-model and truly being enterprise ready. So MarkLogic and Oracle are, in my mind, are the only two competitors in this space. And Oracle has a lot of issues with licensing and complexity that MarkLogic solves. So here is my, this is something I created 8 years ago, my first presentation in MarkLogic, but I think it really captures the meaning of data and how variety is important. This is E.F. Codd's document on data modeling. And he argued 50 years ago, 1970, almost 50 years ago, he argued that we have to get rid of the hierarchical databases. Now think about, wait a minute, isn't document a hierarchy? Interesting. And then he also talks about graphs. We have to get rid of, graphs aren't the solution. MarkLogic's a graph database. So I'm gonna say Codd was right and he's absolutely wrong at the same time. In his time, at this point in time, he was absolutely right. The technology and the concepts didn't exist for hierarchy and graph to work on mainframes. Right? That model didn't work back then, but today it's a different world. We have new kinds of indexes, new kinds of ways of doing things that makes document and graph possible. But back in his day, the answer was, let's get rid of the hierarchy in the graphs and the mainframe fixed structures and move to relational. And it was a database revolution. And so his document, his model talks about all those things. How do we do that? I'm proposing that there's a new revolution going on right now. And this is the document graph revolution. Right? And you're on the one database in the world that can take you to the document graph model. There's no other database that can do this model, and this is the future. I'm convinced of it. I'm a theorist, I'm an analyst, and I've studied it all, and I've been doing this for over 30 years, and I know that this is true. I'm really convinced of this. And so look at this, and I'll show you this in this slide. Notice that this text document has data in it, right? You have a title, that's data. You have an author, that's data. You have a research laboratory, the organization that printed it. You have a location for the research laboratory. You have the publication, information retrieval, and then you have June 1970, a date. You have topics in here. Programs should remain unaffected when internal representation of data is changed. I see a raise of hand real quick. How many of you have changed your Oracle database data structure and never had to touch your code? Never had to touch your code. Have you changed your database? No one's raising your hand? Codd failed. He failed miserably. His dream was an awesome dream and he failed. Right? We need a programming API that you can query and search without changing your code, that the APIs adapt to the changes in the structures. That requires variety, right? Because the problem when you have a fixed database and fixed code, you're tightly coupled, you change one, you break the other. What we need is a variable data structure, a variable coding paradigm, and now you can survive the changes. Now, are you always going to be insulated 100%? No, that's a pipe dream. You're going to have some coupling. The question is, how well can we decouple our code and our data? And so MarkLogic allows us to decouple more than a relational database does. So MarkLogic reaches the dream better in a post-relational world in the document graph world. So another thing, there's a lot of problems with graph and with hierarchy databases back in Codd's day, 50 years ago. Those are the red T's. And then we have categories here. We use references to other documents that are related to this one. So notice how I had a narrative, which was text. I marked up the data inside that text, and now I've said this data is in context of my text. And the word context literally means with text, right? So context. I put data in context of my text. So now the data has more meaning because it's within a bigger context. Notice it takes a document to provide context. You can't get context any other way. You have to have a container. You have to put data in a container. Now you can do that in relational. If you put a view around your data, you can restore some context. Only views restore context. Where are the views? Every query in relational is a view, right? Your SQL statement's a view. And you can materialize your views and put them in the database for performance reasons. But really, the point in relational is you've taken everything out of context, and you have to manufacture a context. In a document, the context is in the database. You've not lost context. That is so fundamental. And now, look what I can do next. Now that I have context around my data, I can, it's contextual information. Now I've turned my data into information, by the way. So By putting data in context, I've made data into information. I've brought it up a level. Now, I'm going to add semantic relationships. I'm going to say EFCOD is the author of this article. It was published in this journal. It was located, the journal's located, or the research laboratory is located in San Jose, California. The publisher of this article is information retrieval, et cetera. It's printed on that date. Here's my related topics. And then here's this topics are related. I can connect topics to each other. These topics are connected. And then I can say, here's a problem topic. This is a problem. This is another problem, another problem, another problem, another problem. And then I can say, here's some solutions. Notice I've just defined the semantic meaning in EFCOD's document of what goes together. What are problems? What are solutions? Now I can query for what are the problems EFCOD's talking about? What are the solutions he's talking about? The only reason I can do that is I did semantic markup within data, and the data's in context. And I can merge search, I can do semantics, right? I've combined all those in one, and MarkLogic allows you to do all of that. One other thing is structural relationships. Hierarchies, EFCOD's document is a great irony to me because he's railing against hierarchies, and yet his document is hierarchical, right? In fact, he's railing against graphs, but everything he's writing is a mental graph, right? You can go and mark it up. And so the document structure itself has meaning. Down here, 1, 2, 3, access path dependence only has context because it's within 1.2 data dependencies in present systems. If you just read access path dependence, you don't even know what he's talking about. But you put that in context of data dependencies in present systems, now you know more. But if you put data dependencies in relationship to the relational model in normal form, the real title of this subsection is relational model normal form, data dependencies in present systems, access path dependencies. That's the real title. But in humans, we take an abbreviation and we break it into structural subsections. Hierarchies have meaning, right? And so when you understand that, now we're not just talking about just an abstract graph and documents, more flexible, whatever. That's just nice. I have now said that documents have meaning, graphs have meaning, and when I combine the structures and the semantic meaning together with the data in context, I get meaningful knowledge. The document graph takes you from a boring set of data out of context and lets you put it in context and turn it into meaningful knowledge, and you can query the knowledge. These semantic relationships are queryable. You can query the patterns of relationships. You can say, give me all the problems, give me all the topics, give me all the solutions to the topics, give me the connections between topics that are problems and solutions. And I can relate it to COD as the author, right? Notice how I'm taking the data and I'm connecting it all together. Now this is all within a document, right? You can do all of this within a document in MarkLogic. What about between documents? Well, let's see. I'm going to jump for time reasons. You can read the slides later. This is one by one points that COD made and the answers that we have today. And the answers we have is that MarkLogic gives us new APIs and indexes that lets us query hierarchy effectively. COD talks a lot about redundant data. When you combine document and graph, I'll show you how you can eliminate the problem of redundant data. And the last one, inconsistencies. Well, relational databases have constraints and triggers. MarkLogic has constraints and triggers. So you can build a database that's post-relational and have a better model, a more meaningful model, and you can have everything you had in relational. Triggers, constraints, and all that. So let's talk about documents and graphs being next-gen relational. So I'm going to talk at a higher level. We talked about what was in a document. Now I'm going to talk about what's between the documents. I have a customer, and a customer makes orders. And I have a triple relationship that says this customer made that, or that order was made by the customer. And then, so now I'm using relationships. That's the traditional relational database model, right? Except that, remember, relational, I've got all these tables shredded. In a document, everything about a customer is in the customer document. But I'm relating the customer to its order. And then I'm relating the order to its products. I'm relating the products to the vendors and the vendors to the documentation about the shipping and whatever else I want to document. That's very simple relational stuff. But you can go beyond relational in a graph because I can relate anything to anything. When I say that, I mean I can relate any document of any type to any other document of any other type. At any time, design time, run time, anywhere I want, with any kind of relationship I can imagine. Now, you cannot do that in relational. Relational has fixed relationships with foreign keys, and constraints are named, but they're named for the DBA to know what constraints are in the system so we can manage it. Constraints have no semantic meaning in a relational database. The irony to me is relational is not relational, right? Relational has constraints. It doesn't even have relations. They're all implied. They're in the head of the designer. How many of you looked at a relational model and went, I don't even know what's here. I don't even know what it means. It's so well normalized, I have to look at the data to get some context to even understand the meaning of my relational model. Right? Relational is not relational. Document graph is relational because I have meaningful relations between my entities. Now we're talking relations. I can write anything. So I could say, hey, this customer got this annual report. I can say this order has invoices associated with it. And I can have printed historical documents associated with the data-driven order. Right? I can show both the historical view and the live view simultaneously. I can have many versions of the same thing. Try to do that in relational. You're going to have a gazillion tables, and it's going to be a nightmare to understand. This makes a piece of cake. I can have product manuals and vendor manuals. So now I'm just relating my data to XML documents. But now I can go beyond that. I can say this customer liked that product. Notice I didn't have to create a new table that is an associative entity that joined them together and change my whole model so I can do likes. I just simply create a triple that says likes. And you could apply it to anything. Any customer could like anything. This product could like the customer, which would be weird, but you could do it. You could do anything you want at runtime. I can say this product, this vendor actually received an RMA on that order. Notice I'm jumping across. In a relational model, I'd have to go down the chain. Now, and I'd have to have more data actually in the doc, and I would change my data structures in the tables to do this. All I have to do is add a triple. And I've now created, I could cut across anything with triples. But notice the pattern. I'm saying everything that belongs in a context is modeled in the context, in a document. And everything that is related within the document is modeled in the document, so you get meaningful contexts. And then I'm saying these documents are related to these documents. See, this is true relational modeling. This is the future. This is document graph, right? You combine the best of both worlds and you get the most meaningful data you can imagine. And the only database that I know of that can do this is MarkLogic because it's combined documents and graph together in one place. You have standard meanings in the industry. RDF has huge ontologies out there that you can just use, and they're predefined, and people know what they mean. So if you start tagging your relationships with those, you can share your data with some other database, and they can share their data with you, and you instantly know what it means. You don't have to go and look at the data and guess. It tells you what it means. The predicate in a triple, triple is just this relates to that. That's all a triple is. And this is an ID, that's an ID, and maybe that's a piece of data. But usually it's an ID. So this ID relates to that ID, and the relationship is an ID too. It's an IRI. But that ID has meaning. So you're really saying this has a very meaningful relationship with that. And these meanings are defined in the industry. So when you model in RDF, you want to model using existing meanings. So your data is integratable. You can pull in data from Wikipedia. DBpedia is the database for Wikipedia. It's a triple database. It's already got all that. Think about it. Wikipedia has a lot of content in it. All that content are in triples. You can download the whole thing. You can stick it in your database. You instantly have all that meaning sitting in your database, and you can link to it. Right? It's free. You just go download it. And the governments all over the world have all this meaningful data in RDF. You just download it in your MarkLogic database and start connecting it. Right? This is the future. Let's move on to data structures. I'm gonna let you read this later when you read the slides because there's too much in this presentation. But I'm going to go through contrasting relational to NoSQL. Specifically MarkLogic here. Notice how relational is fixed and dense. You're fixed at design time, and your data structures are dense as possible. On the right-hand side, we're sparse and variable. In other words, I can have flexibility in everything I do, and I can have sparse data. I can have missing data. I can have 1 million potential columns in a document, and those 1 million columns, I might only have 3 columns that are filled in, if you think of it relationally. Now, can you even do 1 million columns in a relational database? No, you can do maybe 4,000. Depending on the database you're choosing, you have certain limits. 1,000 columns is a lot of columns in a relational table because they're storing things on disk in blocks, in fixed data structures to be as dense as possible. MarkLogic doesn't store things in blocks. I was in the performance training class on Monday, and somebody asked a question about blocks. MarkLogic doesn't do blocks. MarkLogic does files. So we're talking about files containing documents that are flexible structures. So Oracle is, at its core, a fixed engine, and everything is fixed in it. Same with SQL Server, same with DB2. They're all fixed engines. We're talking about the future, which is variable, variety, sparse data, flexible data. And we have to have a database designed from the ground up in its engine to do that very thing. So you can read about rows and documents and how they're different. Rows are fixed, documents are flexible. Tables, MarkLogic doesn't even have tables. It has collections and it has folders, and they have different semantic meaning. But a document could live in any collection. A collection could have any number of documents. It can cut across everything. You can't do that in a table. If you try to do it in the table by putting a type column on your table, try to write SQL to work with that, and then dynamically join based on the type to another table. Can you do that in SQL easily? Dynamically say, read this type, and say, based on that type, join to that table. But now based on the type, join to that table. You can't dynamically do that easily in SQL. That's hard. You have to write PL SQL or T SQL to code to do that kind of thing. That's built into MarkLogic. That's how it works. Flexibility. Each table has 0 to few fixed relationships. MarkLogic has a gazillion relationships, anything you can do at runtime. And then schemas, or tables fixed. You have a fixed schema, but MarkLogic in a database, there's no database schema. You can load any document of any type at any time, and later you can reconcile it into standards. And I'm not saying that you should always be wild and crazy and have any document can do anything that it wants. If you want to run queries and get back the results you expect, you should have at least a viable minimal set, of properties that are the same in every document. Then your queries against those minimal set of properties will be consistent and return you the results you want. But beyond the minimal set, you can have anything. And that gives more context. More context means more meaning. And meaning like provenance. You've heard a lot about provenance, right? Provenance is a meaning. So where it came from, when it was done, when it's effective, all these things we stick in a relational database is these garbage tables like when it was updated on, who updated it by, when was it created on, created by, what's the provenance of this, and you can create every relational model I've ever done is I have like 7 to 20 tables depending on the vendor, depending on the customer. And those columns, those 7 to 20 columns, are just garbage stuff to say the provenance, who did what, when, where, right? In MarkLogic, you can have all that, but you can have more than a few, because those get ugly, right? You look at a schema and you're like, oh, that's just noise. MarkLogic, you can use an envelope pattern, have anything you want in the provenance, but you know your data is right there. And you can even just with one little query, one little point, like in JSON, you just go, I want the data, you just go object.data, and there's your data. You can ignore all the provenance, all that extra stuff, all the metadata, and get to your data just with one little dot in JSON. So it's easy to get to what you want. So let me show you graphically. Relational is fixed and dense. So like you say, you have fixed field types, fixed rows. Every row is the same structure. Now think about that. Every row is the same structure. You think, well, that sounds normal. That's not normal. The real world, everything's different. If I look at you and I look at you and I look at you, you're all different, right? We're all variety, right? If we had to capture you in a fixed row, right, we'd have to have a billion columns in that thing. But in you'd be a whole different set of columns, right? Because you're different. You have a beard, you don't have a beard, right? I mean, you just go on and on and on. The variety. Life is filled with variety. How can we do that in a fixed row, right? You can't. But with MarkLogic, you can have your minimal set of core things that you want to query against, and the rest of them, variety. Fixed table structures, fixed sets of tables. You only have so many tables you can stick in a schema. If you want more, you define more in your metadata, and then you can start pouring data into them. Think of MarkLogic. All I have to do is, if I have data, I just load it. I don't have to define a schema before I load it. If I have it, I load it. Then I can do stuff with it, right? And that's the model of MarkLogic. Fixed table relationships. When you go to a NoSQL database like MarkLogic, and now I can say variable document types. I can have a type that I can specify any document type there. I could even say this document is 5 types at the same time. Think about that. I can say this document is 5 types simultaneously. You can't do that in relational. Table's one thing, not 10 things, right? And I can say this document lives in many collections. I can have variable document structures. So I can say administered drugs could be this, or it could be, I could have anything in this structure. I can add anything I want anytime. Variable data types. Notice I have drug dose size is 200 in this particular one, but below the next record, the next sub-document doesn't have a drug dose size, right? So I have variable data types. There are different kinds of things. So minomycin has different properties than minocycline does. And I can capture that in the record. But again, the minimal thing I require is I need the drug name, I need the drug manufacturer, and the drug dose size for this app to work, and the unit of measure. But beyond that thing for this app, I can have 100 properties that I care about. And they could be different for every different type of minocycline or minomycin or those, I can't pronounce those things, but those drugs. So sparse properties, I'm missing drug dose size on this one. Variable relationships. Now this one, I'm connecting the document number 1, this is ID number 1, and the subject is 1. And so I'm connecting using triples. This is a triple, so subject, predicate, object. I'm connecting this document number 1 through these predicates, through these relationships, to other documents. So I'm saying this document is related in certain ways to other documents. And those are foreign keys. But they're foreign keys done with triples. Triples give me semantic meaning. So now, for the sake of size and the presentation, I say op hospital, because I don't have a lot of room for my predicate. Predicates usually are longer and very detailed and precise and descriptive. This is saying this operation was performed at this hospital. That's the semantic meaning. I just summarized that in this little cryptic op hospital, right? But there's semantic meaning behind that. And I'm saying this operation type, this type of operation is represented by a document 100. And notice down below, I have denormalized properties. I don't have to. Nothing requires me to denormalize. But if I want to, I can stick right in the same, these curly brackets represent a row in a relational, right? And so this is it's an object in an array. I can add any property I want here. So notice how the properties vary based on what kind of documents I'm connecting to. So if I want to denormalize, I haven't lost my context. Now, I want you to think about that for a second. If you denormalize in relational, I start throwing properties from other tables in a table. I've lost the context of the other table. I've not lost any context at all. I've just showed you where I'm linking to. I show you where the record came from. I actually documented through the triple where that denormalized data came from. And I'm putting the denormalized data into this document, so I'm providing more context for this document, because that gives this document better searchability, more relevance, more context. But I'm also connecting back to the original document, so if I want to update them, it's a real easy query to go run a query and update them. So I haven't lost my provenance. I haven't lost the context of the original source. I've captured it all. So graph document modeling takes you to a place where you can connect your data and remember how you connected it and make it meaningful. So I wanted to also talk briefly about XML and JSON, because there's a huge questions. When do I use XML and when do I use JSON? The answer is not use the one that you're comfortable with. Right? Don't use the one that the MarkLogic field rep says, we do this because we always do XML. Or don't use the one that's JSON because I think JSON's cool and hot and it's the most popular thing. There are fundamental differences between XML and JSON, and if you choose the wrong one, there will be consequences. The XML police will get you, right? No. The consequences are XML is for content, JSON is for data. Now there's a bridge between the world. XML can hold data, JSON can hold content, but they're designed for different use cases. XML is designed for, it has a section at the top, it has a root element. The root element defines the type. Notice JSON is anonymous. JSON has no type. JSON, I'll be frank, I like JSON a lot, but JSON was not thought through. JSON, I discovered this back in 2000 when I was built an app server, and you just bring in JSON from your database and throw it into the browser, and you instantly have an object. And you don't have to transform it because the browser can read it, and you have data in your browser. So I was doing JSON back in 2000 when I was writing web apps, because it was a natural thing to do. So that's where JSON came from, is JSON objects, JavaScript objects. JavaScript objects don't need names because you assign them to a variable. And the variable provides the context. But that's not a good data format because you don't pass the variable along with the data. You're just passing, you're dismembering the whole context of what a JSON document is. So what do you have to do? You have to put a type in there. In JSON, you have to say the type of this JSON document is section or something. So JSON doesn't have a type, you have to add it. XML has a whole bunch of stuff that as you read it, you're going like, wow, look at all that weird stuff. Namespaces, I've got comments, I can put attributes in there, I got C data tags, like my brain is exploding, and when do I put data in the attributes, or I put data in the value of the XML and the elements? I mean, your mind can start exploding, because you can do so many different things with it. So complexity is a downside of XML, but also the power. JSON doesn't have C data. C data is fantastic. I can stick anything in C data and preserve it exactly the way I want it. Now in data, you don't care so much about that. If it's a number, it's a number. But if you're talking about text, you might care that it's marked up a certain way. The spaces between words might have a meaning, because humans see space and see meaning. So you lose the space, it matters. So C data preserves everything. It preserves every little punctuation, every space, everything. So C data is very important, and you need it in a text-oriented language. Do you need it in JSON? No, because it's a data language. In JSON, it's simple, easy, and fast to parse. You just have key value, heading, and there's the heading. Right? And MarkLogic, MarkLogic does both. In XML, it's complicated, but you have more power in XML. But where's that power really leveraged? In documents. So if you're doing documents, you want XML. If you're doing data, you can have a choice between the two, but JSON is designed for data. There's some limits in JSON data, and we'll get to that. You can mark up your text in XML. It's best for marking up human natural languages. In JSON, if I want to do this in JSON, I want to put text in JSON, I'm going to have to put a type. I have to create objects, an array of objects. I'm going to have a type that defines what kind of thing this is, and then put my value in it. So I'm going to have to create an object structure to contain my text. Right? So that's the same thing as XML. XML is easy. You just have text, and you start marking it up. If you go to the most complex structures, I can nest elements. Notice I have free text in that paragraph, and I just marked it up. In JSON, it's structured. I can't just throw text anywhere in JSON. Text has to live in an object, right? So you have to create objects for everything. Over here on the left, I have XML allows data to be in there. I can nest data in there. I have a date, and I have a date type, and I have data in there. I can freely mix elements. I can tag anything in XML to the text, but again, I start with text, I mark it up. Over here in JSON, I have data built in. I have strings, I have numbers, I have nulls, I have booleans. JSON does not have a date data type. It doesn't have a time data type. It doesn't have a date time data type. It doesn't have a duration. JSON is not well thought through, because JavaScript was a quick language they put together because they couldn't use Java in browsers. So it's not a bad language. I like JavaScript, but it's not thought through for the purpose. So it has problems, but it is simple. It's designed to create structures and load data into them. Dynamic structures. JSON is just as flexible as XML, but XML is built for text. JSON is built for data. And lastly, I can have sprinkle tags within my text in XML, but I can't sprinkle tags in my JSON. I have to create new objects, and I have to define the type of those objects. So the bottom line is, if you read on the left in the yellow, you can read the text. Right? You can just read the text in XML, and you just, in your brain, when you start to train your brain in XML, you're reading the text and ignoring the tags. And eventually you look at a tag when you care about, oh, it's marked up for this and it means something. Over here on the JSON, what are you reading? You're reading the structure. In JSON, you always look at the structure. The data is not the important part, it's the structure. So there's exact opposites. Right? So they're very important that you get this difference, because you choose the right tool for the right job. The problem with JSON, you should understand though, that JSON, every number in JSON is a double. It's a floating point double. Every number is, whether it's an integer or whatever, it's stored in JavaScript as a double. That's the standard. So you have binary rounding errors in numbers in JSON. In XML, everything is text. So what does MarkLogic do? You say, well, that element is a decimal, and it's a base 10 number, or that number is a double, or that number is an integer. So you can specify the data type in XML, because XML is just text, and MarkLogic interprets the text as a real thing. And MarkLogic, you can do that in JSON too. You just have to put the number in a string. Now, it seems really weird. Why in the world? It's a typed system. You're putting numbers in strings. Well, because numbers in JSON are doubles. And if you don't know the problems with floating point numbers, come talk to me, because that is a nightmare. Doubles are an artifact of 50 years ago, when they didn't have the space to, they had to compress everything and do things in binary for speed. Back when we didn't have any CPU power, we didn't have the space, they're an abomination. Doubles are a bad idea in a decimal world. Okay, so that's a little rant there, but I'm going to now go on to customer model. Now this is a relational model, very high level. This is the Northwind data model. And you take this, And I'm going to just take the customer table, just that table alone. And if you really want to model customers in a real-world model, then you turn it into that. That's a real customer model. Right? And I built these kind of things. This would be modeling like a customer on Amazon. If I do that in, and notice that it's 13 tables, because you can't do multiple values in one column, right? A column is single valued, so you have to blow it out. The problem with relational is you can't have multiple values in a column. Object relational you can, but no one does that. And it's not the right paradigm because SQL doesn't query it well. So relational does not allow you multiple values, but JSON and XML do. This is the same, so think about that 13, all these tables over here on the right, that's the same thing in JSON. Now look at this is data. I'm doing JSON because I'm talking about data, right? And look at that, you can read that. I don't think I have to explain anything on that page to you. Notice the context is self-explanatory. The hierarchy tells you, the names I give it, and names in XML and the names in JSON can be as long as you want. They're not 31 characters like in Oracle. You don't have to abbreviate things and confuse people to take something cryptic and make it more cryptic, right? You take things out of context, now let's abbreviate it, and so you can't understand it at all. I mean, that's terrible. This you can describe exactly the way you want it, right? You know I'm a person because it says it's a person. There's schemas. This is actually 3 types of schemas in one. I'm subclassing. In relational, if you know subclassing, that's hard to do, and it's very confusing. And there's 3 ways to do subclassing in relational. In this, all I have to do is put different objects in here. I have a person object, I have a customer object, I have a company relationship object. I'm subclassing by just creating new objects in the same document, and I'm defining the schemas for them. So I'm typed, but the schemas are minimal required. I'm not typing everything because I want flexibility. Well, if you don't want flexibility, type everything. But but if you want to do it the flexible way, just type the bare minimum, and everything works great. This is a realistic customer order model. So going from that 13 the original 7 tables, which is the quick and easy, academic model. This is a real world model for building customer orders. But this is the same thing in document model. I want to go back. That is relational. That is document graph. Now, this is not academic. This is real. The human brain understands documents and graphs, and I've simplified all my multi-values into where they belong, in the document, right? And that simplifies everything. Now think about your modeling for the business. Does this remind you of logical modeling and business modeling, right? The physical modeling is this ugly relational structure. You don't show that to the customer, right? You show this to the customer, and then you turn it into that ugly thing because relational databases can't handle multi-values because they're flawed. That was a compromise made in 1970. That's not a mathematically correct approach. It was the only way they could get their brain wrapped around it, right? And it's not even based on data algebra. They call it relational algebra, but that's not true math. And I've got some books on real math, real data algebra that talk about it. So there's a lot of FUD and a lot of misunderstanding about the relational model. So this is the true model, and notice I really have 1 document for each customer, 1 document for each order, 1 for products, 1 for vendors. This is the same model in data. Now notice you're not only seeing the structure here, you're seeing the values. Although I've overlapped them, it's kind of hard to see values, but the green are the values, the blue is the structure, right? So notice that's the exact same model as this complicated one here. That's relational, that's JSON. Humans can understand this, and the business understands this. This is the real world. You're modeling the real world, and you're not turning it into some horrible thing that you can't understand. You can understand the whole thing here, and it's more meaningful. It's flexible. It has semantics. It has meaning. This is totally transformational. This changes the world and data modeling. There's a whole bunch more. I don't have time in this presentation. You can read these things, though, because I wrote the slides so you can read. So I intentionally added more here than I could get through because I wanted you to take some time to look. But you can go through, here's how you normalize. Here's how you normalize in document graph. Here's how you denormalize in document graph. Here's how you orthogonalize in relational. Here's how you orthogonalize in document graph. Here's how you generalize, and here's how you generalize in document graph. Here's how you tune in relational. Here's how you tune in document graph. These are high-level things, but you can get the ideas as you read through the slides. JSON is simple. It's performant. If you want to look through the IOs, you probably want to study the IOs here and how IOs work in relational versus document. You'll be amazed. Relational makes you do 5 to 1,000 times more IOs than a simple document model, and it's explained here. Multi-valued, multi-type, that's the coolest thing. And MarkLogic's new Optic API allows you to query across all this variety. So that's a huge piece to get us to the world of document graph, because they've merged in one API the ability to query documents and query graphs at the same time. So the Optic API is the bridge for the document graph model of the future. And templated data extraction as well. That's all part of that. And then multi-values. Notice the simple little thing here. Having an array for address purpose. The purpose of this address is multiple context. It's a shipping address, and it's a mailing address. I mean, isn't that a common thing, right? You ship to the same place you mail to. And so what do you have to do in relational? I have to have a separate table entry or separate row for each of those things. I didn't have to duplicate the data, by the way. The same data for the address is there. All I had to do is to have a multiple value purpose. A simple array. Boom, I'm done. That is transformative. Look how easy and intuitive that is. In relational, that's a nightmare. Right? You've seen, I have to create an associative entity on the right to do that. That's a pain. Okay, so then I'm going to show you real quick, multi-typed. I can have different objects with different types in them. Again, relational, try to model that. It's going to be a huge number of tables. You can do it, I've done it, but try to write SQL against it after you modeled it. Good luck. This is trivial in a document model. Everything is data. Everything is data. The structure is data. If you want to change your structure, write a query and change your structure. Query, you can write DDL and change your structure in relational, but can you write a query, a data query, and change your structure? No, everything's data, so this changes everything. You have easy, simple data types, you have meaningful data modeling inside, and you have meaningful data modeling outside. Inside documents and outside documents. So I believe this is the future, document graph, and MarkLogic is the only database I know that gets us there, but I hope there's more databases in the future, so there's lots of competition. Thank you. So we're out of time, but you're welcome to stay and ask me a few questions between sessions.